All right. I'm Bryson Wingate, and this is Signal Relay, a satellite ground station simulation for Project 5. And I'm going to go ahead and get into it. Now, essentially, you're running a ground station for one shift. Three connection slots on this disk requests come in on the right here, which can be labeled as research, comms, or emergency. So as you can see, we essentially got a drag from the dish to the to route bandwidth essentially, and then the bar fills and the ring counts down as a time limit since that's the deadline. And now there's only three slots, so you have to triage. So I'm going to connect two at the same time, and then the more I run at once, the faster the heat climbs. Essentially, past once you pass the yellow line, essentially, I'm throttled, and then the bandwidth essentially slows down. Well, as you can see, we don't get to really hit it unless we get like a whole bunch of requests at the same time. And if you hit the heat limit, you essentially get a full lockout, which all three connections will drop, which is in which you can't have any new connections for about 8 seconds, and then anything you were servicing is temporarily paused. Now I'm gonna let this one miss. Now, once you see it, there's gonna be a straight reputation hit, and reputation is the win condition essentially. Now, if reputation gets down to zero, then the shift ends early. But survive a whole 6 minutes, you'll get a day complete summary, essentially as a win condition. So let's try and do. See, as you can see, you have to sort of. Essentially, it's kind of hard to lose, essentially, unless you like really let it pile up. If you just like let the heat to like kind of affect you, then yeah, then it's capable of losing. So I'm gonna leave that and go to the GDD. Now, section one here is the pitch and the scope ceiling. The core fantasy here is being a competent operator under pressure, not exactly a hero, but every failure should feel earned and not random. And in the scope, 1 6 minute run, three fixed slots, three request types, the heat meter, and reputation as the win condition. Now, out of scope, and I documented why for each out of scope thing, multiple dishes, persistent upgrades between runs, weather events, and all three would have essentially added a fourth system competing for the same attention as my actual three. And as for success criteria, for example, he has to cross the throttle threshold at least twice in an aggressive run, or the mechanic isn't actually reachable in a normal play. Now, as for system architecture, we essentially have here five modules, and essentially each owns its own thing. And and here I labeled it in a table what each module owns, what it sends, and what it receives. So, example, Station Core owns time and a reputation. Bandwidth Router owns the slots. Heat Manager owns the heat, obviously, and Request Queue owns spawning and deadlines. And I'll walk through the actual code against the table in a minute. Now, as for mechanics, I'm going to here I specify each of the three mechanics along with the trigger effect and every tunable parameter, at least with three edge cases. So starting with bandwidth routing, you have to drag to essentially bind a slot, 10 units second delivery. Now now for the second one, heat throttling, you have to it's like a gain per active connection minus passive decay. The throttle is at 80 units and the lockout is at 100 units. And then lastly, the priority deadline queue request spawn on like a ramping interval with type specific deadlines and reputation values. Now every number here was uh, was a decision I had to defend later because some of them turned out wrong once I actually built-in system, in which I'll get to that into the postmortem. Now, as for the player experience design, the target feeling here is challenge, but with fantasy as like a secondary. And expected dynamic is that the players have to develop their own triage. Here's it's like their own triage strategy, like self-limiting to two slots after getting burned by a lockout once. I designed a positive feedback loop, like clearing requests early gives you some headroom, and a negative loop that greedy routing builds heat, throttling makes you fall further behind, which risks a lockout that cascades into more misses. And I also specified how exactly how a first time player learns the game within the first 5 seconds with zero written instructions beyond one caption. Now, as for section 5, here I got the data structures and algorithms such as the station object, the request object, and the drag state. I initially chose distance based hit testing over precise polygon testing because it's cheap and forgiving, and then I also chose continuous per frame heat integration over fixed ticks so that it stays accurate regardless of frame rate. And of course, for my library, I chose Vanilla JS and Canvas with no external libraries on purpose so that the build time went into tuning the three mechanics instead of an asset pipeline. Now, as for UI and flow, we go from start into playing, uh, game over. We have screens such as starts, playing, game over, day complete, and exactly what's on the screen during play, like the clock, the reputation meter, the heat gauge with a throttle line, the dish with its three sockets, and the request queue with the deadline rings. And this is basically the spec I built render.js against. Now, out of scope and future work, like I said, we had the multiple dishes, the persistent upgrades, the weather events, and a manual heat vent button I specifically decided against because it would let players opt out the exact tension the heat mechanic exists to create. And lastly, the open questions are, of course, the ones I flagged before actually building anything. Is three slots actually the right number? Does the spawn ramp feel steady in practice? And should a missed request get partial credit? And two of these actually turned out to matter a lot once I actually started simulating the runs. Now, as for the code architecture, I'm going to show you the actual code against that systems table. Five files, one per system. So let's go with station core first. And go down to the apply reputation delta function essentially. So station core essentially owns the time and the reputation and sort of some of the run state. Now one function, the apply reputation delta, is the only thing that's allowed to touch reputation, and as you can see, everything else essentially reads it here. Now back to it. Next one is bandwidth router. And I'm going to show you here the start drag. Now, here, now bandwidth router essentially owns the three slots in the drag state, like the start drag, update drag, and end drag functions. So those three functions handle the input. Get heat generation rate reads the connected request and computes a weighted heat contribution and that one function is actually where the file reaches into request queues data, which I'll flag again in question 4. The next one here is heat manager, and I'll go to the tick function. Now, of course, heat manager owns heat, throttle, and lockout, and the tick takes a rate, integrates it, and flips throttle above 80 and triggers a lockout at 100, which again calls back into bandwidth router to force clear every slot essentially. Now, next one is request queue, and the main function here is spawn request. Now, request queue, this module owns the appending list spawn timer, deadlines, and again, tick spawns on a ramping interval and checks every request deadline, um, each and every frame, miss or complete, and both go back to the station core's reputation function. And lastly, render. And I'm going to show, let's see, of course, draw frame. Now, of course, render.js reads all four of the other files and writes to exactly none of them. It, it also exposes the get dish center and get request card rectangles, which bandwidth router calls for drag hit testing so that the collision math always matches on what's exactly drawn on screen. And now for the four required questions. Well, the first question, the most important design decision and what I gave up. Going back into request queue. Let's see. Now most important decision. I had to tie spawn rate to reputation, and in so doing, well, in so doing this raises the pressure of instead the difficulty being purely time based. Now, what I gave up here was my safety. The first version existed at 0.03, let even the most cautious strategy lose outright in the simulation. So I pulled it back to here, 0.02 to keep a safe floor. So the trade-off here was a more dynamic curve in exchange for a much harder balancing problem. Now for question two, my most and least confident systems. Let's go to station core. Now my most confident here is station core. It's small, isolated, and every function has a headless test, and it never needed a fix after it was first built. And least confident again was request queue. Now the spawn pacing, I had to retune it three separate times, and every value came from a handful of simulated runs, and but not an exhaustive search. And to actually fix that, I'd want hundreds of simulated runs across strategies instead of eyeballing four or five. Now to break the three ways to break the game, let's go up to bandwidth router. Now here, the first one is the browser console. Everything is a plain mutable object on signal relay, so anyone can essentially call apply reputation delta. Where is it? Re- Apply to reputation delta directly, and no authority boundary at all, basically. Second, the backgrounding the tab like I'm currently doing right now. So my loop See, as you can see, my loop computes delta time from real elapsed time, but come back after at least 30 seconds, and one frame could instantly max heat or complete several requests since nothing clamps down delta time. And third, the exact frame that the heat hits 100 and causes a lockout. Slot binding and force clear both write the same array with no lock in between them, so that could easily cause a glitch. Now, as for the unplanned mechanic interaction, all the way back to request queue, the interaction I didn't plan for was the reputation feeding into the spawn rate of requests, which actually feeds into heat. The architecturally, I did handle it gracefully. Request queue already got current time from station core, so adding reputation through the same channel was a clean and small change. But the consequence that success could easily snowball into failure wasn't something the architecture predicted, and that was a balance problem I caught only by simulating it. Now, as for the postmortem here, what went well, the modular architecture let me build and test one system at a time. What went wrong? My original spawn interval numbers were just plain wrong, and heat and lockout basically never triggered in real play, and I didn't catch it until past my near final build. And what I would do differently is build my headless simulation harness from the start instead of part way through. And every pacing bug here that could have been caught at least 2 or 3 commits here sooner. And that is Signal Relay, the repo, and the GDD. And of course, the post written postmortem is linked in the submission. Thank you for watching.